now we are recording. So once you get into Blackboard, all you'll see is this announcement. Where the useful stuff is right here, where it says course information. First thing you see there is my information, my contact information. First of all, you guys can all call me Todd. We're all adults here, so we don't need to worry about titles. Next is the syllabus, which I'll show you in a minute. The third thing that's here right now is my schedule. As you can see, it's a little bit of a tight schedule, but I have classes before and after yours every day. But if you need to get a hold of me, this 10:30 to 11:30 time, I'm usually free except for on Tuesdays. If you're coming, if you need to find me, I'll be in this room usually. I don't hardly ever go up to my office. I go up there for maybe 30 seconds a day to see if anybody dropped off an email or anything for me. That's about it. Otherwise, I do have that activity hour on Tuesday and Thursdays, but after we get a couple weeks in, I start having meetings during a lot of those times. But come and check. If you catch me before I leave for a meeting, I have no problem skipping a meeting to work with a student. Okay, then the syllabus will be here. Open that up. We'll come back to that. And then what will normally appear down below here are going to be the recordings. I'm going to take you to a class from last semester so you can see what that looks like. So here when you click on course information, you see all the same stuff I just showed you, but then they got these links to the recordings. Now sometimes you can click on it and it'll open up. A lot of times you have to copy and paste it into the browser. And you can see it takes you to YouTube. You gotta wait for their ad because they gotta pay their bills too. And what comes up is just exactly what would appear up on the screen.
And we talked about the
sound laid over.
The number yesterday. So
that's basically it. You know, feel free if you want to put them up on the big screen at home, pop some popcorn, invite over some friends and neighbors, view the class. I get half of the gate if you charge admission. Okay, so back to the syllabus part here. So here's my contact information again. Email is probably the best way to get a hold of me. I have email right here in the classroom, so I check my email a couple times a day usually. If you can't, you can call any of WITC's numbers, any campus, and dial my extension. It'll take you to my voicemail. Other than that, like I said, if you need to find me in the building, look in this room first. What's this class about? Well, these are the topics for the class. We start out, it's pretty basic to start out with. We're doing calculations with whole numbers, fractions, and decimals. It's a little bit of a review of basic math. Then we do proportions, percents. We'll do quite an extensive unit on measurement conversions, and dealing with units. For this group, we'll also do micrometers and calipers. Make sure you know how to read those. Then we do solving equations, algebraic equations, and then some basic geometry at the end of the course, depending on how much time we have left. Now, if those topics are looking pretty easy to you, there is a test out procedure. It costs $20 per credit. This is a 2-credit class. It costs you $40 to try the test out. You have to take the test out in the first week of class, so sometime this week. And if you pass the test, you have to have 80% to pass. If you pass the test, you get credit for the class. You get a refund on your tuition, which would be like $290 or whatever it costs for this class. I mean, your $40 to take the test out is gone either way. But if you don't pass the test out, you lose your $40 and you're stuck back in here. If it's something you're interested in, come talk to me. I'll show you some types of problems to expect and stuff like that. The pass rate on that test out, even though, I mean, you look at these topics, it's stuff you have already had in high school. Historically, the pass rate on that test out has been surprisingly low. And we're talking like about a 1 out of 3 that try it actually pass. So don't go in there blind. Come and talk to me if it's something you're considering. I don't want to see a waste $40. Textbook. You guys should have a little green custom publish. Yep, that's the one right there. That's actually part of a textbook. As you're looking through it, you'll notice there's pages missing. That's because it's just selected chapters out of a book that we looked at. It saves you about $120 off the purchase price when you go to buy it. This is still like what, 160, 170 bucks, something like that. Or not that bad. Somewhere in there. The trade-off is, because it's a $300 textbook if you bought the whole thing. The trade-off is when you go to sell it, these aren't worth anything because they're a custom published book. So you save the 120 bucks up front. You don't get your 30 bucks at the end of the semester when you go to sell it. Other supplies, it is highly recommended you have a scientific calculator. Not required, but highly recommended. People always ask me, can you use your cell phone? I won't stop you from using your cell phone, but most cell phones don't do a lot of the functions really well. They can be difficult to use. If you don't have a calculator, the one I recommend is the TI-30. In fact, it's the TI-32, TI-30 with the Roman numeral 2 after it that I usually recommend, and get the solar. Just because I have like a half a dozen or more of those sitting up in my drawer in my office upstairs with dead batteries in them. It's only like $12 or $13 for a new calculator. It's like $8 for new batteries. So the solars will last you quite a long time. The only reason I recommend the TI-30 is it's probably the easiest to use. Casio and the others, Hewlett-Packard and all those have, Sharp have ones out there that might be a couple bucks cheaper, but they're a little bit more difficult to use. One thing I'll warn you, especially this time of year with the cold weather, we're going to get some more cold blasts before it's done. Don't leave your calculators in your car overnight. Every year I have somebody that does it, and they come out to use it, and the screen is black. It blows the LCDs in the display. Okay. Grading, I'm sure it's the part you've all been waiting for. This course, you will have unannounced quizzes, and then you have unit tests. There are 5 units, 5-unit tests. The last one we may not completely get to. So those unit tests are each worth 100 points. Quizzes are worth anywhere from 8 to 20 points, depending on the size of the quiz. Usually those will come every 3 to 4 hours of class. So you may not have a quiz yet this week, but if we don't have a quiz this week, I guarantee you there'll be a quiz probably Tuesday of next week. So they come up pretty quick. The reason for that is it gives me a way of monitoring how you guys are doing so that I can tell if you're missing something, so I got time to go back and cover it before we get too far off. The other 20% is homework and attendance, or homework and participation, I guess I should call that. I will never collect your homework and grade it. That's why I do the quizzes so often, is so I can monitor it that way. I have somewhere, well, actually this spring I'm a little bit low on students. I only have like 107 or 108 students. But even with that, I don't have time to collect and grade everybody's homework every day. I just couldn't keep up. So for me, the homework is a tool for you guys to learn, to figure out what you need to do and what you need more work on, what you understand and what you don't. And I'll trust you guys to monitor. So basically that 20% of your grade is show up for class, don't upset the teacher. If you're really concerned, bring donuts. No, just kidding. Coffee. Yeah. When it comes to the homework, by the way, since I don't collect it and grade it, now I still expect that you're going to work on it, but I don't necessarily expect that you're going to do every problem, especially here early on in the class. You look at some of the first problems on the homeworks are pretty simple. What I expect you to do is do 1 or 2 of the first ones. If they're really simple, skip ahead a few problems. Don't just skip it completely, because sometimes it's really easy to look at what's going on in class and think I got that, but then if you try to sit down and do it yourself, it's a different story. So make sure you at least look at the homework and do some of the harder problems at the end of the assignment and make sure you've got it down. Yeah. Well, the bright side of the story is this is my 17th year here, and I teach this class every semester, spring and fall, and usually 3 or 4 sections in the fall and 1 in the spring. So you're looking at, probably somewhere around 68 to 70 times I've taught this class, and only once in that time have I had somebody that showed up every day, did all their work, and didn't pass. So the odds are in your favor. This is the standard WITC grading scale, what we go by for this. Withdrawals and drops. There are deadlines out there for withdrawing or dropping if you have personal reason you got to withdraw, or if you're worried about grades or whatever and dropping to deal with grade points. The only thing I really say about dropping or withdrawing from a course is don't just do it on your own. Make sure you talk to someone. At the very least, talk to Rick and Jeff. And I prefer you talk to me before you drop, because there are a lot of things that, a lot of times you're not doing as badly as you think you are. I have a lot of students that look at their grades and think, oh, I'm doing horribly, I got to drop. And it might just be a test that you haven't made up yet or something like that, and your grades are actually pretty good without that in there. Also, there's always, a lot of times there's unintended consequences. Like if you drop below a certain number of credits, you might have financial aid consequences and stuff like that. So they said make sure you talk to at least one of us, if not all of us, before you make any decisions like that. Policies and procedures. Well, you guys have probably already gone through the internet policies and all that stuff. Don't do anything naughty on our school equipment. Academic integrity, don't cheat. Accommodations, if you need anything, whether you have a diagnosed disability or like you said, you've struggled with math, or maybe pressure of tests gets to you, talk to us. We'll figure something out to help you out. We can almost always figure out something that makes life easier for you. Podcasts and videos. As I said, this class is recorded, and they are posted on YouTube, which means they're open to the public. So be aware of that. If you have any issues about being recorded or whatever, come talk to me, and we'll make sure we mute the microphone or something every time you talk so that you're not on the recordings. And then these are the 5 units we're going to go through. So any questions on policies, procedures? Like I'm sure you've seen enough of those in the last couple of days to never want to see one again. Now, you saw the content of the course. The topics are relatively easy. So why at a college level course are we going through some of that basic math again? Well, there's a few reasons. One, to refresh. Some of you have been out of school for a while. Maybe weren't great at it when you were in school, and you want that little review to get back into it. 2, I found through the years that a lot of the struggles students have with the more difficult concepts, like the algebra and stuff like that, come from not truly understanding what's going on with the basic concepts. You know how to do it, but you don't know why you're doing it that way. And so we take a little bit of time at the beginning of these courses to go back and talk about why it is things are done the way they are. For example, probably the most basic topic in math, but also one of the most misunderstood topics, is the concept of a number. Show of hands, if I put a 4 up here, how many of you would tell me that that's a number? Most people would, right? Technically, however, that is just a numeral. It is an amount. It tells us how much. To truly be a number, it not only has to tell us how much, but it has to tell us of what. Like we might have 4 cows. So we have that amount, the 4, which I'm going to refer to as the count. And then it tells us of what, which is the cows, which I'm going to call the name. Now, some of you might be thinking, oh no, another one of those math teachers is going to make us label everything, or he's going to mark it wrong. That's not my purpose here. I'm not, going to be strict about units or labels or anything on your answers. I want to show you those 2 parts because as we look at our basic math operations, the 2 parts each do have a very distinct and important role. So let's look at our most basic math operations. Addition and multiplication. I heard you even start to say subtraction there. A lot of times people are like, well, where did subtraction go? Well, technically addition and multiplication are our only 2 basic operations. Subtraction is not really an operation on its own. It's a part of addition. It's a byproduct of addition. You can think of it as addition being done in reverse. Addition is going forward, subtraction's in reverse. And the same with division, yes. So any rules that apply to addition also apply to subtraction. If I haven't mentioned it, I am a very poor speller. So if you see me like lock up like that, a lot of times it just means I got halfway through the word and I forgot how to spell the rest of it. So if anything appears up on the screen here that you can't read, I assure you it was intended to be English. I probably just butchered the spelling. So don't be afraid to, and I also have sloppy handwriting sometimes too, so don't be afraid to put your hands up and ask me what something says. I won't be offended. So let's look at addition or subtract. Let's do inches here. Let's do like 4 inches plus 7 inches. What do we get? 11 inches. Well, that right there is going to be worth your $300 for the course, right? Not yet? Okay. Well, let's look at our count and our name. Let's see what happened. We have our counts here, the 4 and the 7. And we combine those to make 11. So we combine the counts. We're adding, so we combine them with addition. So let's look at the names. We have inches and inches, and we end up with inches. So when we add numbers or subtract, we keep the same name. And I might be looking at that, well, okay, that's not real significant yet. Let's look at multiplication. Let's take 4 inches times 7 inches. First of all, is everybody familiar with the dot for multiplication instead of the x? Okay. So what do we get when we do 4 inches times 7 inches? 28, not inches though, but inches squared. Think about it, if we're multiplying two lengths like that, chances are we're looking at a rectangle or whatever, and we're calculating an area. So if we look at our count and our name here, we have 4 and 7. This time they became 28. So we still combine the counts. This time we're multiplying, so we combine them with multiplication. The difference here is the names. We had inches and inches, and they became square inches, or inches squared. When we multiply, we also combine the names. I might be looking at that saying, oh, big deal. That's kind of a really small point to make such a big deal about. But it really is a big deal. All of the special rules we've learned for working with our other forms of numbers come from this little concept here. In fact, this idea, this small difference between addition, subtraction, and multiplication and division, defines what numbers we can even use in each operation. For example, let's say I have 3 cows plus 5 boys. Do I get 8 cowboys? Does that work? I don't think so, right? Or if I do it the other way around, 5 boys plus 3 cows, do I get 8 boy cows? Not likely, right? Anybody with a farming background here? Yeah, you can tell me that is a whole bunch of bull, right? Long way to go for a joke. But there's a point behind it. The point is, when we add numbers, we're going to keep the same name, which implies we had to start with the same name. Here, when we have cows or boys, we don't start with the same name. We don't know which one to keep, so we cannot combine those with addition or subtraction. A little bit more of a practical example there might be, let's say I'm going to do 5 feet plus 2 pounds. What do I get? Well, I get 5 feet and 2 pounds. Those have different names, so I cannot add or cannot combine them with addition or subtraction. However, when I multiply, I'll put the number in there. When I multiply, I'm going to also combine the names, which means I do not have to start with the same name. I'm going to do 5 times 2, combining the counts makes 10. Then I'm going to also combine the names. Feet times pounds is foot-pounds, which is a unit of torque. Yep, we'll touch on that a little bit too here. But yeah, that's the. Yep, and that's what all those little rules like that, like you just brought up, come back to this basic concept. How do you deal with X and Y? How do you deal with fractions? How do you deal with decimals?
If you did say 4 inches times 7 inches,
Yep.
Whatever
Inches cubed, yep. Yep. And that is actually a distinct unit. An inch squared, and an inch cubed are 3 separate units. Let's look at a different form of number here. Let's look at everybody's favorite. Fractions. Yeah, I know. I hear the groans. So if I ask people on the way in the door what they hate most about math, I'd say 4 out of 5 people would say fractions. The other one would usually say the teacher. A little review. The top number of a fraction is called numerator. Bottom number, denominator. Well, every 10 years, our government sends out people to do the census, to enumerate the population. What are they doing? Counting. That's just a count. A denominator, well, we have different denominations of money, different denominations of organizations. To denominate means to classify or to give a name, to give a title or a name. So the fraction has those 2 parts. A lot of people look at a fraction and they see 2 numbers, but it's really one number with 2 parts. Just like having 4 cows, here we have 4 sevenths or 4 inches. It's the same thing. The top number, the numerator, is how many we have. We have 4 of something. The denominator is just telling us of what. It's our name. So if we go to do any operations with fractions, let's say we have 2 sevenths plus 3 sevenths. Somewhere around 3rd or 4th grade, when you first started working with fractions, your teacher told you to add or subtract fractions, you must have common denominator. Not a special rule for fractions, because anytime we add numbers, we must have the same name. When we add fractions, how did she tell you to do it? Combine the numerators, 2 plus 3 is 5, and keep the common denominator. Again, not a special rule for fractions. Anytime we add numbers, we combine the counts, and we keep the same name. It just looks different because it's in a fraction form. If we were multiplying 2 sevenths times 3 sevenths, how are we taught to multiply? Well, straight across. You're thinking reduction, cross canceling, cross reduction. And we multiply straight across. Numerator times numerator. 2 times 3 is 6. Denominator times denominator. That should be 7 down there, not a 3. 7 times 7 is 49. So to just multiply straight through. Numerator times numerator, denominator times denominator. Again, that's not a special rule for fractions. Anytime we multiply numbers, we combine the counts and then also combine the names.
When multiplying fractions, that's common denominator.
Yep, we're going to hit that right now. So if I have 3/4 plus 1/5, can I add those the way they're written? No. We'll talk about, when we get to fractions in more detail, we'll talk about changing the denominators, changing their names so that we can add them. For right now, we just know those have different names. When we multiply, do we have to have the same name? No. So we don't have to have a common denominator. We're just going to combine counts. 3 times 1 is 3, and combine names. 4 times 5 is 20. That's it. Let's look at another form. A decimal, 0.21. Now the formal way of writing that is 21 hundredths. You could do it as over 100, make it into a fraction if you wanted to. So if we're going to add 2 decimals, let's say I got 0.21 plus 0.3. Is that going to work? Why not? We've been told that when we add or subtract decimals, we have to line up the decimal points. Why? You told you have to line up the columns, right? Well, why? There you go. We can only add things that have the same name. Right now, this is 21 hundredths. This is 3/10. We have to add a 0 to make that 3/30 hundredths. And then when we add, the decimal points automatically line up. 21 and 30 make 51. Where's the decimal point go? Straight down. We bring the decimal point straight down because 21 hundredths plus 30 hundredths has to be 51 hundredths. When we add, we keep the same name. So all those special rules for decimals, lining up the decimal points and bringing the decimal straight down when you add or subtract, those are the same as our rules for any other type of number. You must have the same name, and then you keep the same name. If I'm multiplying, I'm not going to worry about lining up the decimal points because I don't have to have the same name. 21 times 3 is 63. Where's my decimal point go? Is it right here? Got to add a 0 there. Why do I need to put a 0 there? Yeah, we were taught you count 1, 2, 3 decimal places in the problem. So you have to have 1, 2, 3 decimal places in the answer, right? Why? Third grade teacher said so. Because this is 21 hundredths. This is 3 tenths. (21 times 3 is 63), but we also combine the names when we multiply or divide. Hundredths times tenths is thousandths. So when we're counting up those decimal places in the problem and putting that many decimal places in our answer, all we're doing is combining the names. Some people get a little nervous when we start mixing variables with our numbers. But again, we have a count and we have a name. Just like 4 inches, 4 cows, 4 sevenths. The difference is we know what an inch or a cow or a seventh is, and we're not necessarily sure what an x is. But for mathematically speaking, or for our operations, it doesn't matter. 4x plus 7x is going to be 11x. We combine the counts. 4 and 7 make 11. We keep the same name. 5x plus 2y is 5x and 2y. 5x plus 2y. Just like with 5 feet and 2 pounds, we can't combine them with addition or subtraction because they have different names. If I'm multiplying 4x times 7x, perfect, 28x squared. We combine the counts. 4 times 7 is 28. And then just like inches times inches became inches squared, x times x is x squared. Just like having 5 feet and 2 pounds, we couldn't add them, but we could multiply them. 5 times 2 is 10. And yeah, just like feet times pounds became foot pounds, x times y is xy. It even goes through to scientific notation, which we'll talk about a little bit later on in the course. But if I have like 3.2 times 10 to the 5th, the name is really the power of 10. That's defining the place value. 3.2 is our count. So when I go to add numbers in scientific notation, I have 3.2 times 10 to the 5th. They must have the same power of 10 because they have to have the same name. Then I'm going to combine the counts. 3.2 and 5.3 is 8.5, and I keep the same name, 10 to the 5th. That's just the number I put out there. If I were multiplying, let's say I were multiplying 3.2 times 10, I'm going to change the powers of 10 here. 10 to the 7th times 1.8 times 10 to the 3rd. I'm going to multiply the counts. 3.2 times 1.8 is 5.76. But then I also have to multiply the names. Now, we haven't learned how to deal with powers yet, but 10 to the 7th times 10 to the 3rd is 10 to the 10th. You add the exponents, yeah. So we multiply or divide, we also combine the names, just like any other form of number. Now, what ties all of this into what we do every day? It's another very basic concept called place value. Place value is another one of those very, very simple concepts, very basic concepts that most people don't see the full picture of. We're just going to see the very beginning of this picture today, and we'll look at more of it tomorrow. But we start at the end of the number. I always say the decimal point, just because there is technically a decimal point at the end of every number if there's no other one in it. What's this last digit called? The ones. And then tens, and next hundreds. And those are our three place values. They are repeated over and over again. Ones, tens, hundreds, ones, tens, hundreds, and so on. Repeated over and over. This is what we refer to as our base group. This next group, of course, is the thousands. And then millions and billions and trillions and so on. When we name a place value, we name its place value, and if it's in the base group, we just name its place value. But in the other group, we name its place value and its group. So this is just the tens place. Well, this is the 10,000s, this is the 10 millions, and so on. Now, I'm not going to go over how to pronounce a number. I'm going to assume you guys got that down at this point. But I am going to look at something like this. 7,284 is how we're used to seeing that number expressed. But that is really just an abbreviation. The full form of that number, or what some books call an expanded form of the number, is this. 7,000s, yep, 200s, 8 tens, and 4 ones. Written out like that, you can see what each of those numbers means. Each digit has a count and a name. This isn't just a 2, it's 200s. This isn't just an 8, it's 8 tens. And tomorrow when we look at our basic operations, all those rules we learned for those basic operations are explained by this expanded form of the number. Now, some other things I want to show you that are important for place value. Before we go on to that, rounding. Now, if I ask you to round 5,852 to the nearest thousand. 6,000 is the answer you're going to get, yes. What it's really asking you to do is this. What that's saying is if we have a number line, and this number line is labeled in thousands. And if I put this number, 5,852, on that number line, which of those thousands is it physically closest to? It's closest to the 6,000. Now, you don't want to draw out number lines every time you go to round numbers. So the shortcut we've learned is rounding to the nearest thousand. What's the thousands digit here? That's the 5. We look at that next digit, and that tells us. The 5 is telling us that we're between 5,000 and 6,000. That next digit tells us how far we are between. 8, of course, is way over here. That's telling us we're closer to the 6, right? If it's 1, 2, 3, or 4, that's definitely closer to the 5,000. 6, 7, 8, or 9, those are all definitely closer to the 6,000. The problem comes, what if that digit is a 5? Let's say that this were 5,527. What would that round to the nearest thousand? Still going to be 6,000. We've always been told that if that, here's our thousands digit, if that next digit is a 5, we've always been told we round up, right? We've always been told we just accept it. Well, really, if we're looking at this, it's not just 5, it's 527. Technically, it is slightly past the middle. So the reason if that next digit is 5 that we always round up is most of the time there's other digits after the 5 that put us more than halfway there. The only time it would be a real issue is if that number were exactly 5,500. Now it is exactly in the middle. Now convention is still we round it up. There are some applications out there, and we're not going to go into them because I don't want to confuse you, of like mechanical design and mechanical engineering, where if you rounded all those up, you'd end up with a lot of round off, call it tolerance buildup or round off buildup, where if you're adding a bunch of numbers and they're all rounded up because of the 5s, you're going to end up with a huge error. So there are some applications out there where they round some of them up and some of them down. If it's something you're interested in, I'll show you outside of class sometime. Come and ask me. I'd be happy to go through it with you. For right now, we're just going to leave it as, for us, when that next digit's a 5, we're always going to round up. Since we've got the number line out here, I'll show you something else significant from the number line. You've seen this one before, right? 8 blank, put in the symbol, less than, equal than, greater than. What symbol goes in there? Less than. Which one's less than? This one or this one? First or second? The first one is, right? Yep. Yep, that's the way to read it. Where did that symbol come from, the less than symbol? 8 is on that side of 12. It's actually the arrows off the end of your number line. The alligator eats the bigger one. Yeah, there's some that I've learned. Some of them aren't politically correct anymore. But like the alligator eats the larger animal, or the bigger guy points and laughs at the little guy with bullying. That one's not acceptable anymore. But yeah, we can handle it, right? I guess for today, I'm going to call that enough. I'm not going to give you any homework today. Don't get used to it. We'll almost always have homework unless there's a test. And normally what will happen is, this is a 3-hour-a-week class for 2 credits. So it's supposed to be 2 hours a week of presentation and learning activities, and then an hour a week of guided homework time. So normally what will happen is I will lecture for 30 to 40 minutes. The last 10 or 15 minutes will be homework time, depending on how you guys work. Yeah. So you should have time to get a good chunk of your homework done before you leave here every day. The only time I ever take that homework time away is if I have some groups that when I give homework time, they like to try to jump up and run out the door. As long as you're in here working, we'll make sure you get some homework time every day.